Okay, first of all, I'm very grateful for my previous speakers to giving me a bit time before coffee break. So if I run out of time, I'll just try to make use of it. Yeah, so thank you everyone for coming today. And my presentation today mainly focusing on what is Google doing with geospatial and with all this new era of AI and reasoning, and also in the context of just geospatial as well, because we have multiple platforms in this area. So I want to share what kind of changes, trends we see in this area. And if you look at like the major things I will be talking about in the presentation is first is more looking on the planetary scale analysis focus. So we saw some examples where you want to zoom in specific area, but sometimes you want to really do analysis at really planetary scale. And so of course, we see trend with like cloud native architecture. That's what currently becomes the mainstream, or it's already mainstream. They sharing real-time data sets. So they are, we saw from previous speaker also that valuable information, insights you can get out of this data if you have really real-time data for many applications. And the rise of use of AI or machine learning or LLMs, you could call natural language processing models, applied, combined with other types of models or component. That's also a kind of important topic to address. If you look at like what Google is doing or was doing, so we have a long history of working with geospatial data for all types of products, starting from Google Maps, which now turned 20 years. So it's used by billions of people, of course, but there are also a few other platforms. So we have BigQuery, or we have Google Earth Engine working with raster data, Vertex AI is kind of new, let's say the new service in this area. And that's all of this getting integrated, and we use it internally also a lot, of course, to make sure that our maps are up to date. You get 3D tiles and all types of improvement in our also consumer products, but as well as our services that are available for everyone. And that includes also data sets. So like we had multiple announcements. It's a bit, a month ago, we had Cloud Next, like large conference where I probably get like largest number of geospatial related announcement. Like Weather Next is one of our top model, which does global forecasting, also operational forecasting, which we now distribute in BigQuery, Earth Engine. We started working, or we constantly working on integrating different systems with each other. So we announced another connector in BigQuery that now you could query raster data from Earth Engine natively, and really connects these thousands of different raster imagery data sets for more geospatial analytics applications. So in BigQuery, you basically had extension in SQL language. You can call S3 region stats, where you could reference data sets, image data sets, and basically get insights in BigQuery for data analysis. But also going the opposite way. So we realized that working with platforms like Earth Engine, which has its long history, it's very good for image processing, but it requires quite a lot of skills also to manage. But people who work there with vector data, we felt they were limited. So the moving this data around was not easy. So we added another connector where in Earth Engine, you would just write SQL query, querying data from BigQuery, and that goes backwards. And it scales quite nicely, so you can combine and analyze these data sets easily. But if I step back a little bit and look at like what does it take actually to build something like Google Maps, and when you build planetary scale analysis, not just focus on one system, but more building the product or doing analysis at this level. So you really need global infrastructure. So you want to deliver data everywhere. You want to do it secure way. So if you look at mobility data, you don't want this data to leak anywhere. So you have to do it responsibly. And that's like the way how we approach this. And another thing is also having, let's say, the addressing different diverse data. So we saw also from Javier's talk, like LiDAR and other data sets are not even kind of mainstream maybe for geospatial analysis, but they are really useful assets that you need to process internally to keep your data elevation models, in this case, maybe up to date, as well as any location-based data mobility data, cars, street view. So some of these data sets we also collect and combine, aggregate. And then, of course, you need to keep it fresh. So the mobility data, location data, business locations, all kind of information related to this. If you want to offer this to your users or build services on top of it, this needs to be really kind of up-to-date data. So there's a lot of work to be done. And many of these services also, we distribute some of these data sets or access to our data through Google Maps platform. There's a number of APIs, a lot of companies, organizations using it. And we added, like one new thing, what we added there is, was announced last month, is that we started adding what we call geospatial analytics data set. So this is in the right column here, and that's what I will mention in the next kind of part. And this mainly related to three types of data. So one is related to routes, another to places, and the third one to maps, so imagery. And they were still early in this stage, kind of opening this data, access to data for geospatial analytics. Of course, raster imagery data, they are available, but they are also not kind of with addition of this SP region stats, we basically make it more available for geospatial analytics, because you would require some skills to work with this data. So if you look quickly on these types of what it means, places, roads, and other. So for places, it's any information, not like I think we try to open up, let's say, as much as possible, all this information, access to this information for analytics. But basically what it means is that any information about businesses, let's say the aggregated maybe review or opening hours on types of businesses, it's something that it's possible now to, and it's in preview products, so you could subscribe to these data sets, and then from that point you could run geospatial queries to create kind of aggregated statistics on these variables on your, within BigQuery, and then put it on maps, of course. When it comes to routes, it's all information about routes, road segments, geometries, so you can select some of these subsets and then basically subscribe to this data and store traffic information related to this roads, to this routes. So that's another type of products which are now in the kind of early preview. There is a sign-up form where you can express your interest and kind of get to this data. But basically, this would allow organizations to learn about the disruptions, different patterns in let's say, related to roads. And the third one is probably the early stage, is more what we call imagery insights. So we have places insights, road management insights, and this imagery insights. That's more related to analyzing the data like street view or overhead imagery, high resolution. So there is a lot of course, assets built we have at Google, and we're trying to kind of make some of these data sets accessible for kind of more applications. Okay, that's more about some of the recent announcements or changes. If you look at, now let me switch gears to AI and reasoning. This is like quite new area for me, to be honest. I was working with some machine learning data science application, but I'm not expert in LLMs. I did few kind of simple analysis, and so I started now explore like what's happening there, and I was fascinated by work of my colleagues from Google Research, which I will show shortly in a while. But also I try to kind of explore a bit from what's other things happening in the geospatial context. So I want to share some of my findings here. And so if you look at the, let's say, let me turn on the video here. This is 1 minute, so I will just stop talking, but just show you what this announcement is about. I hope that audio will work.
From maps and trends to weather, floods, and wildfires, Google has studied the geospatial world for decades, and we've made that information accessible through AI models and real-time services. But synthesizing across these models and combining your data with ours can be challenging and expensive. That's why we're introducing Geospatial Reasoning. You can now bring your data and models together with Google's geospatial tools for easier analysis using Gemini's reasoning ability. Gemini plans and enacts a custom program, searching over data and gathering inferences from multiple models to unlock powerful insights, all through a simple conversational interface. Geospatial reasoning can be a critical tool for advancing public health. Climate resilience. Commercial applications. And more. Let's think bigger, together with geospatial reasoning.
It's a bit marketing, you could say, like pitch video for technical audience here, but I want to also use the rest of time to deep dive a little bit on what actually it means and how you would work with this. So if I look at this research, and there is a blog post about this, and otherwise you can find Devin Schottlander, who is author of the blog announcing this research here. So use opportunity to talk to him. And my understanding was, maybe I will, I did not study in all details, but what Javier mentioned in his first presentation is this agentic approach, where you would have specific agents which can be LLM based or can be just also tuned to work with specific type of data source and aggregate it in some way. So this is all kind of brought together into some agentic, let's say, framework. And the word reasoning or thinking, this is still, my understanding is that it's still a debate in the research community, like how much LLMs can reason and what is actually reasoning or thinking. Is it like comparable to human? So it's still evolving, but this was like interesting to see that it's possible to actually combine all these different data sources, platform services together, wrap with something like LLM, and then actually make a useful tools that can help us to develop things faster. So that's one part, and I think there's a sign-up form. You can express your interest, and like we plan also to release some source codes related to this larger multi-agent kind of model. And one thing which you can already try, and this is something was developed by my colleague Simon Ilushenko, and so it's more in the context of Google Earth Engine. So I know that Google Earth Engine is a quite complex system, more from point of view of API, to actually start using it. The way it works, server side, and you have to write code in API of Earth Engine can be kind of challenging. And then that's why I really recommend to kind of test this, give it a try, this tool called EE Companion. And the way it works is, and that's something what I will show here, is that, it's based on LLM model for adding reasoning capabilities to work with Earth Engine. But from that point, when you run this notebook, it's you could just type questions in the code or in a prompt here, and it will actually generate code which runs on Earth Engine and will show you data. And this was for me like eye-opener that it's possible. I always thought that it's more a toy, but it's actually becoming very useful assistant when you don't know Earth Engine API even, or if you even know to do some tasks faster. And the way it's implemented, it makes use of something called Gemini function calling, where you could define prompts. So when you have how this LLM-based agents work is that you would have an LLM model which is trained on large amount of data, all types of text, and kind of, so that's what NLP does. So it knows, or it doesn't know, it's memorized a lot of patterns and knows, basically trained on a lot of data. So there's a lot of knowledge in there, but really steering it or doing selection there, maybe a good analogy, like if you work with raster data, you build like pyramids and indices with vector data, and you would, if you zoom in some area, you would just do lookup and maybe interpolate between pixels. In this case, you would do something similar. If you think it in this way, that it's just a large knowledge database where you could kind of make queries, go zoom in some area, interpolate, extrapolate, maybe hallucinate a little bit. That's what LLM is. But if you combine it with like tools that can gather data and can do some tasks in real time, you could build kind of useful tools. But this is a Gemini function call, and it's what's used there. And so what I did here, I hope it won't break because I did not do any, this is live testing. So bear with me if if some things will break. But if you look, at this notebook, what my colleague developed, it's the way it's organized. There's no any kind of large components in there. There's just one library called functions, which just adds some kind of overhead syntactic sugar to link things together, plus integration with Colab Python kind of notebook. The rest is just prompting. So it uses one of LLMs, and you define prompt where you say, okay, you are an agent that can generate Earth Engine code, and here's Earth Engine API, and you will do these tasks and give some kind of steering of this LLM to do things properly. So like, okay, when you run code, what will happen if there will be error, and how you can evaluate things. So this is what the only thing what happens what's in this prompting. And from that point, you could actually start asking questions in just plain language related to raster data, to imagery data. And so what I did here, I ran this notebook. There is some kind of helper code here to just do wiring of things together in Colab. And so when we run, I think here, let's keep this code. We don't need to check it. Just go into this part. Yeah, so there's one place where you have to connect to actually LLMs that you are using. So my colleague, so Simon, he tested it with different types of LLMs like Gemini, and ChatGPT and others. And once you connect, so you would have to provide Google Cloud Project and access to Gemini API key. Once you're there, then you could basically run these agents, and you will get this type of screen where you have a map here on the right. The model itself for this agent, it doesn't know anything about maps, so it will only use your text and translate it to code. So what it will try is, okay, generate composite 20% percentile image using Sentinel-2 for Hyde Park in London. This is pretty complex question. Like I did not expect, honestly, that it would be able to reason and do something with this type of questions. And I hope it won't fail. So what you see here happening is that there's kind of the icon going on, which means that it's running code, thinking, and the code might be failing, but it actually generates just Python API based on this question. And of course, it's based on some lookup of what you had maybe on Stack Overflow or in some examples or in books. But like here, it's now generates some strange feature collection. At some point, it zoomed in this map to Hyde Park, and now it's added base map, which is based on Sentinel-2. It's a true color band combination. So adding more questions, say, oh, I want to do it in false color. So like, can you add a layer in false color band combination using sphere, near, and green. Let's see if this will work. And it's quite, I did not check the depths of the lookup or thinking, understanding, whatever you call it, reasoning, but it's, yeah, so now it's used different bands. And I didn't even look at the code like that it generated. So it knows which bands correspond to this specific false color or true color. You could also ask like, okay, generate me code for code editor for Earth Engine for JavaScript. And this was quite impressive for me. So it's already a useful tool. I'm certainly gonna use this as a system. Even I've worked for many years with Earth Engine. I know how to write well code there, but when you can do things quickly and instead of spending an hour or half an hour, I can do some quick wipe coding, wipe remote sensing code in Earth Engine using this assistant, that's kind of already helpful. So this is, let's say, almost end of my talk. Meanwhile, while let's say Javier was showing presentation, I tried to actually ask, so if you, maybe you use or you don't use the Gemini advanced, so if you go gemini.google.com, there is you could select like different models, but there is a new option was added a few months ago called deep research. So I try to use now more and more this type of just general LLMs for answering general questions. So when you work with research, it usually takes quite some time to do research. So I ask LLM here, okay, are LLMs able to reason? And the answer is it does quite advanced analysis. And this is also the way it works. It's also agentic, you could call it, because it uses real-time sources. So it learns using kind of base knowledge which sources to look at, but it actually does on-the-fly fetching of the data and using real-time data and comes up with some results, which was, in this case, the main conclusion was that it mimics reasoning, it finds some specific patterns, and it's very similar to reasoning, but it's in terms of novelty, of creativity, of flexibility, still like it doesn't replace humans. So it's really think of it as assistant or as a kind of your dictionary, but more smarter dictionary. And also this ability to tune it to do specific tasks. Then it becomes this powerful tool. And this is, I feel like, what's happening currently as trend to transform, as this AI or GOI specifically transformation. With this, I will finish my talk. So thank you for your attention, for listening.